Okay, so here we are. We're going to produce a video explaining something about trigonometry. So I need a right angle triangle problem to explain something about trigonometry. And I know it's a right angle because I have a right angle there. So if this is the small angle, which side is the hypotenuse? Well, that's the longer side of the triangle. It's that one. Which side is the opposite? Well, that's the side that's opposite the angle. So it's way over here. Opposite side. And we have the adjacent side of the triangle, which is next to the small angle. Okay, let's have everyone focused. So we've got a lookout tower has been erected on top of a cliff. Girls. And at a distance of 5.8 kilometers from the foot. So that there is important information, so I'm going to underline it. And the angle of elevation, and I remember elevation means it's a looking up angle, to the base of the tower is 15.7 degrees. Okay? And to the observation deck at the top of the tower is 16 degrees respectively, as shown in the figure below. So how high from the top of the top of the cliff is the observation deck? How high is the top of the cliff? From the top of the cliff is the observation deck. Alright, so let's try and visualize this and draw a picture. So we've got some cliff. Okay, and on top of the cliff we've got an observation tower. Might look like that. Okay, sure, sure. And we have some distance away, 5.8 kilometers away, from the foot of the cliff. We have a person looking up. So an angle of elevation is a looking up angle. So yep, my tower. What's your tower look like? So I've got two angles looking up. Quiet down, please. From here, I've got one looking up angle to the top of the tower and another looking up angle to the top of the cliff. Jesse, stop talking and work. Alright, from the information, what is the angle of elevation to the top of the tower? Angle of elevation to the base of the tower is 15.7. Observation deck at the top of the tower is 16 degrees. So the one that looking up to the top of the tower, the larger angle there, 16 degrees. And then one to just the base of the tower or the top of the cliff, which is up here, 15.7 degrees. So I might show it like that to put some information in. And there was another piece of important information in the wording, is the distance from the foot of the cliff to a point where we're observing. So from here, where over here is a distance of 5.8 kilometers. Okay. So I've got two right angle triangles there, and what I'm interested in finding is the height, looking up. Most important, the height from the top of the cliff to the observation deck. So it's this section, from the top of the cliff going up. That's the height I'm after. Do I know the height of the cliff? Any information about the height of the cliff? What do you think? Is there any part in the wording that describes how high the cliff is? Carmen, do you see anything? No. Anyone else? It tells you the angle looking up to the cliff, but it doesn't tell you actually a length in height of this cliff. So we've got an extra unknown in there. Okay. So what do I know in this part? I've got two angles. I've got a 15.7 degrees to the base of tower. Okay. I've got and 16 degrees to top of tower. Okay. Summarizing your information from the instructions from the question helps you to make sense of all the information in the question a lot better, because when you write in your own words and think about it yourself, you can grasp the ideas better. Okay. And then we've got some distance, 5.8 kilometers from base of tower, base of cliff, to point of observation, looking up. Okay? All right. Now, from this, what's most important is what do I need to find? The goal of the whole question, do I need to find the height of the cliff as the goal of the question?
No.
What is it? What's the goal of the question?
Top of the cliff to the observation deck.
Yes, the top of the cliff to the observation deck. So that's just the height of the tower. Okay? Very good. Height of tower. So I may need to, in process of doing that, I might need to figure out the cliff, the height of the cliff, in addition. But primarily, the most important thing, the goal at the end, is the height of this tower. Okay? All right. Now, what kind of operations do you think I might be using? This is, what are the rules or maths working out I might be doing?
What number is that?
Well,
The black one.
yeah, sure. I got it from the distance amount written in the question.
She can't read it.
Yeah.
Can someone read that out for her? Yeah. That information is a distance, and it is, same as that, 5.8 kilometers.
What does the picture say? The black writing.
Yeah.
No, next one.
The picture.
Down here,
Yeah.
yeah, I just explained to you.
Oh.
It is this distance amount here, 5.8 kilometers. All right, I draw on my diagram the information described in the question. Okay, that's the important part when you're trying to solve and you're drawing a picture about it. All right, now I've got right angle triangles. Do I have any information about hypotenuse length? None whatsoever. So out of our three rules, which of the three rules do you think I might be drawing on? I'll be using if I don't have any information about the hypotenuse. TOA, that's right. Tan rule. It's definitely going to be the tan rule, because that uses just the opposite and the adjacent side lengths. Okay? So, the rule or operation I'm going to be using is tan of the angle is the opposite side over the adjacent side. Okay? Now, I've got two right angle triangle problems, don't I? I've got the smaller one, which involves the cliff, and I've got the larger one, which involves the tower and the cliff together. Yeah? So let's just look at just the cliff. Okay? Now I've got the opposite side here is the height of the cliff. Whoop. The opposite side there is the height of the cliff. The adjacent side is the distance that we're standing away. So using those two pieces of information, I can see that tan of the small angle of the small triangle, which is going to be the blue one, the 15.7. Well, that is the height of the cliff. Okay? I'm just going to use a symbol to represent the height of a cliff. What do you think is a good symbol to represent height of a cliff?
C.
Good. Well done. C. Just to note down that C is this height, the height of our cliff. All right? Which is going to be some number. And that's my opposite side, and I have to divide by the adjacent side. The adjacent side is a length 5.8. Okay, so how do I rearrange this rule to work out the height of my cliff, C? Yes?
5.8 divided by 10.
Almost.
Oh, I mean
You're
times.
very close. Times. When I've got the height of the cliff up here in the numerator, then if I multiply by 5.8 to the other side, that will give me the height of a cliff. So, I whip out my calculator. And I'm doing something like 5.8 times 15.7. Try that again. 5.8 times 15.7. Tan of that angle. Okay, so I set it up with 15.7 degrees inside the tan rule times 5.8, and I get a value of that. Okay, 1.6 kilometers high. That's kilometers, by the way. 1.6 kilometers high. You know, lengthy cliff. 1.63 kilometers high. Cool. Sorry? If it's a cloudy day, you might be struggling. That's true. Okay. Now, let's keep going. That's the height of my cliff. How am I going to get the height of the tower? Well, I've used the small triangle with the small angle. Yeah. Now, if I have a look, how can I use the next observation of 16 degrees looking up to the top of the tower? Okay. So that's going to use for me another tan rule, where the angle now is 16 degrees, and the opposite side of this large triangle is not just the height of the tower, but the height of the tower and the cliff combined, the total height. Okay? So maybe I can use another symbol to represent the total height. T. That sounds good. So sometimes it's important to label what I'm going to use to explain for a number that I have here. T for the total height of the tower and cliff. Okay, so then tan of the angle is the same as the opposite side, being T, the total height. Opposite divide adjacent, and the adjacent is the distance we're standing away again, 5.8 kilometers. Okay, so that's the rule I have. What will be the working out, or the way I would rearrange that rule to work out what's the total height now? Zach? What would the total height T be the same as? Remember the little trick we did when if we get a rule and we have to rearrange it? We had this triangle tool that we could use, yeah? So, looks like this. Everyone should have this in their exercise book and refer to it when they're stuck and they don't know how to rearrange the rule. Like that. Now, if we are after the total height, what side of the triangle is the total height again? There's the angle. It's the opposite side of the triangle, isn't it? So if I'm after the opposite side of the triangle, I cover up the side I want to work out and see what's left. The adjacent side next to the tan part. What operation is happening when they're next to each other? Multiplying. That's right. So it's the adjacent side number multiplied the tan part of the rule. Tan part of the rule, the adjacent side is 5.8 multiplied tan of the angle. Stay on the video, please. I'm showing you. Okay. Do the same in the calculator. What do we get? 5.8 times 16 degrees tan of that angle. And I get 1.66 kilometers. Okay, so I know the total height of the cliff face and the tower, and previously I worked out the height of just the cliff, 1.63. So how do I then use those two pieces of information to get just the height of the tower? What could we do? Yes? Any ideas? Subtract them. Very good. Which ones do we subtract? So tower height. The tower height is then going to be equal to, we take the largest height altogether, which is your total height. And we're going to subtract the cliff height. Okay? So what do we get for our final result? Total height being 1.66. And we subtract the height of the cliff only. So we start with the whole lot and we subtract just the cliff height, and that gives you the tower height. So that gives you 0.03 kilometres,
30 metres.
which is, Lloyd, 30 metres. Well done. You're right, 30 metres. 30-metre high tower. Okay? Excellent.
Or